All right, equivalent fractions is just another way to say that something is proportional. I like proportions a lot because we get to use, well, different methods. Methods that you've probably heard of before. But we may look at this a little bit differently. And I apologize in advance if you feel like it's childish. But it allows us to draw in math, which is kind of rare. So, number one, circle the fractions that are written in lowest terms, meaning we can't simplify them any further. This will require some factoring, essentially, okay? Assume no variables are equal to 0. So let's look at these. So really it's just asking, is there a fraction that is equal to this that we could make this smaller? Well, 12 and 28 are even at least, okay? So we know we should be able to divide both these by 2. Okay, now what this does is it gives us an equivalent fraction, but we're scaling it down. We're scaling the numbers down to smaller numbers. 12 divided by 2 is 6. 28 divided by 2 is 14. Well, these are also even numbers, so we should be able to divide these again by 2. And yes, I know some of you guys already knew that was, both of those, 12 and 28, were divisible by 4. It doesn't matter how you do that, okay? So 6 divided by 2 is 3, and 14 divided by 2 is 7. So simplified, fully, we get 3/7. It's important to remember on this, too, that if you do it to the numerator, you got to do it to the denominator as well. Otherwise, you're actually changing the value of the fraction. So 1/7, well, 1's pretty simplified. So this one's good. This one is simplified. 13/15, well, 13 is prime. Now, if 15 were divisible by 13, perhaps we could simplify that, but it is not. So this is simplified as well. We'll circle it. This one's a little tricky because they use letters, the jerks. But if we think about what is happening here, hopefully it makes things a little bit easy. This is n divided by n. What's anything divided by itself? It's close. Now that's what we want to say just out loud, right? It's just 1. Right? I mean, if we did 5 divided by 5, we'd get 1. -8 divided by -8 is 1. Anything divided by itself is 1. So E as well, 3 divided by 3, that's just 1. All right, complete the following equivalent fractions here. Now, there shouldn't be too much tricky stuff on this. So there's a couple ways we can look about it, and they gave us plenty of examples to do this, okay? So the method that we used to scale those other ones was, that's called scale factors. So if we know, for example, 12, if we do something to 12, we should get 6. Now this only includes multiplication and division. So 12, what would I do to 12 to get 6? Yeah, right, you divide that by 2. Well, remember, in order to keep the fraction equivalent, if we divide the denominator by 2, we got to divide the numerator by 2 as well. 4 divided by 2 is 2. Now, of course, 2/6 could be simplified, but that's not really what they wanted us to do there. So this is a scale factor method or scaling method, which allows us to either scale the numbers up or down. I'm not going to worry about the other methods unless we see a problem that's a little bit more complicated, all right? So, for example, this one, the same idea. What would we do to that 5 to get to 15? Yeah, you'd multiply that by 3. Well, again, if I did it to the bottom, I got to do it to the top as well. They've already made it negative, so we don't have to worry about that. 8 times 3, 24. And then this one again, with the negative stuff, they've already made it negative, so we don't got to worry about that. But what would we do to 8 to get to 4? Yeah, divide by 2, right? So I got to do it to the 4 as well. 4 divided by 2 is 2. Write an equivalent fraction for -5/6. So this is what we got, right? -5/6 with the denominator of 18. So it's going to equal another fraction, but now I've got a denominator of 18. So that's how this sets up. Again, it's like the problems we just did. So 6 times 3 would give us the 18. So 5 times the 3 would be 15. And the actual fraction is the whole answer for this. Number 5, negative 15 18ths.
From 7/14.
Let's look. So you divide it by 2 first, right?
Right.
So dividing both these by 2, we get 7/14. Well, 7 is prime, but 7 goes into 14. So what this means is that we can divide both of these by 7,
Okay.
which would give us 1/2. Okay, well, there is, yeah, okay. This one, just off the top of my mind, I'm looking at this. They're both divisible by 2. I mean, that's a quick one because they're both even. So let's do that first. 30 divided by 2 and 56 divided by 2. This will give us a negative fraction just from the negative in front. 30 divided by 2 is 15. Over 56 divided by 2, 28. Well, this is another way we can look at this game. Is we got 15, right? The prime factorization for 15 is just 3 and 5. Both of those are prime. So the fraction really is negative 5 times 3. The 28 splits up into 7 and 4. 7 is prime, and then 4 is 2 and 2. So this is 7 times 2 times 2. See how there's no common factors between these two numbers? What that means is that there's nothing that we can divide by itself here. So that means that this can be simplified, and that right there is our answer. I'll show you how to use this type of method, if it's preferable, here in a moment. All right, so I'm going to break this down into prime factorization. Now I got that negative 28. I'm just going to slip that out into the front of that fraction, so I don't have to worry about the negative stuff. So 28 splits up into, again, 7 and 4. 7 is prime, and 4 is 2 and 2. So this is 7 times 2 times 2, right? Sorry, that looks like a Z. And then I got 63, which breaks up into 7 and 9. And then 9 breaks up into 3 and 3. So this ends up being 7 times 3 times 3. So what this means is that if I have a match in the numerator and denominator, I can cancel those out. Because 7 divided by 7 is 1. So this ends up being negative 2 times 2 is 4, and 3 times 3 is 9. Number 14, here I'm going to show this using that prime factorization stuff. Now it should help to remember what the exponents mean. So in this problem, we got that x squared, and again with the negative I'm just going to slip that out in front. X squared is just x times x. And in the denominator, we got that x. So we're done with the x's. Let's look at the 18. 18 splits up into 2 and 9 or 3 and 6. Doesn't matter. And then 6 can be 3 and 2. All three of those are prime, so 3 times 3 times 2 times x. And then 6 splits up into 2 and 3. So here I'll just reorder those, 3 times 2. Now I'm just looking to see what I can cancel out on this thing. So the 3's cancel, the 2's cancel, and the x's cancel. Notice what happened to the denominator right there. There's nothing else in there. So, I mean, if we really want, we can tag on a 1, or we can just ignore the denominator from here on. And I get negative, we got the 3 times the x. Now if you put that over 1, I'm okay with it. It means the same thing. But some people are really picky about that and don't want you to show it. Negative 3x. All right, so 15. So I can break this up into, it's really just breaking this up into two parts, okay? So I can get this 3 over 15. I can simplify that because both these are divisible by 3. 3 divided by 3 is 1, and 15 divided by 3 is 5. Now I look at my x's. So x cubed would be x times x times x, and divided by 5 x's being multiplied, x to the 5th. And then I just look and see what cancels out. 1, 2, 3 x's cancel. Now these two x's that are left over were in the denominator, so we'll just keep them there in the fraction x squared. That's it. So this is another one of those tricky ones. 117, we can see 1 plus 1 plus 7 is 9. So it's divisible by 3. So 117, let's look at that first. Breaks up into 3, and then I get 39. And this breaks up into 3 and 13, both of which are prime. So this ends up being 3 times 3 times 13 times 3x's. 36, on the other hand, should split up quite a bit. 9 and 4, which splits up into 2 and 2, and 3 and 3. So this is 3 times 3 times 2 times 2 times 1x. And again, we're just looking for stuff to cancel the 3's and one of the x's. So in this final fraction, we have the 13 and then the 2 x's. And in the denominator, 2 times 2 is 4. That's it. Now this one has 2 letters. A's do not cancel out B's, and B's do not cancel out A's. So when we do this one, I kind of have to split it up into these parts, okay? The a cubed has nothing else to cancel with in the denominator anyways, so it's just going to stay. So let's look at 36 over 45. Both of these are divisible by 9 or 3, but again it doesn't matter. 36 divided by 9 is 4. 45 divided by 9 is 5. So dividing by 9 just saves us a little bit of work, and so this ends up equaling, we got a 4 and a 5 right there. Now the a cubed, there's nothing to do with that, but the b's, we got b squared, b times b over 5b's. And these cancel out these ones. So in the denominator, we've got these 3 b's, b cubed. And we simplified it. Now when we're comparing fractions like this, it's good to have common denominators so we're comparing the same size pieces, right? For example, if this was a brownie tin, would have 10 pieces that are 1/7 size. Right here we have 10 pieces that are 1/5 size. And yes, some of you guys know that one of those size pieces is bigger than the other, but let's just double check, okay? So what's a common multiple of 7 and 5? 35 would work, okay? So to get 7 to be 35, I'd have to multiply 7 by 5. But again, if I do it to the denominator, I got to do it to the numerator. So this is 50 35ths. Now to make the 5 a 35, I'd multiply that by 7, but the 10 as well. So this is 70 35ths. Well, one of these is bigger, and since we're comparing the same size pieces with the 35ths, now we can say that 70 35ths is certainly bigger than 50 35ths. So the answer on this one is less than. Yeah, this one, pretty rough, right? So let's change this one into an improper fraction so that we can compare this other improper fraction. Now I'm doing this. You could, since we are comparing fifths to fifths, You could change negative 17/5 into a mixed number, but for me, it's easier to change this mixed number into an improper fraction. Negative 2 times 5 is negative 10 plus the 3, or with the 3, would be negative 13/5. Now, we do have this negative 17/5. And this is where it gets really tricky, right? Because in our minds, we look at this and say, oh, yeah, 17 is definitely bigger than 13. But would you rather owe someone $17 or $13? Hopefully the answer is 0 overall, but in this case, we don't have a choice. I'd rather owe them a little bit less.